The colonization of Venus, though a fascinating and highly speculative concept, is not currently a reality. However, it is a subject of much discussion in science fiction and space exploration circles. There are various challenges and opportunities that would come with attempting to colonize Venus, and the idea has captured the imaginations of scientists, futurists, and writers alike. Below is a detailed exploration of the challenges, potential methods, and ideas around Venus colonization. Venus's harsh environment. Venus is often called Earth's twin planet because of its similar size and composition, but it is vastly different in its conditions. Some of the key characteristics that make Venus inhospitable include surface temperature. The surface of Venus averages around 467 degrees Celsius, 872 degrees Fahrenheit, which is hotter than Mercury, despite Venus being farther from the Sun. This extreme heat is caused by a runaway greenhouse effect, where thick clouds of carbon dioxide trap heat in the atmosphere. Atmospheric pressure. Venus has a surface pressure that is about 92 times greater than Earth's, which is equivalent to the pressure found 900 meters, 3,000 feet, underwater on Earth. This high pressure makes it impossible for human-made machines to function on the surface for long periods. Atmosphere composition. Venus's atmosphere is primarily composed of carbon dioxide, 96.5%, and nitrogen, 3.5%, with clouds of sulfuric acid. This creates a highly toxic, corrosive environment that would quickly destroy most materials that are not specially designed to withstand such conditions. Acidic clouds. The clouds are thick and composed of sulfuric acid droplets, making Venus's atmosphere not only dense but also extremely corrosive. Wind and storms. Venus experiences hurricane-like winds at high altitudes, and the winds near the surface can reach speeds of up to 350 kilometers per hour, 220 miles per hour, adding to the difficulty of sending probes or rovers to the surface. Colonization ideas. Despite these challenges, several theories and proposals have been suggested for how humans could colonize Venus or at least establish a permanent presence in its atmosphere. These ideas generally focus on exploiting the upper atmosphere of Venus rather than attempting to land on its hostile surface. Floating cities or habitats. One of the most promising ideas is to create floating cities in the upper atmosphere of Venus, where the conditions are more favorable than on the surface. Around 50 to 60 kilometers, 31 to 37 miles, above the surface, the pressure is similar to that of Earth's surface, and temperatures are more moderate, around 30 degrees Celsius or 86 degrees Fahrenheit. Some proposed methods include aerostats, floating balloons. These would be large, gas-filled balloons that float in Venus's upper atmosphere, where the temperature and pressure are more manageable. These floating platforms could be designed to house humans, research equipment, and industrial infrastructure. The use of hydrogen or helium to buoy the structures would help keep them aloft. Cloud cities. Building on the concept of aerostats, researchers have proposed the idea of cloud cities that would hover in Venus's thick clouds. These cities would be made of materials resistant to the harsh atmospheric conditions, such as carbon composites or other advanced alloys. They would be designed to withstand the acidic and corrosive environment. Solar power and energy. Given Venus's proximity to the Sun, solar power could be a highly effective energy source for these floating cities. Solar panels could be used to generate electricity to power life support systems, atmospheric processors, and other critical infrastructure. Terraforming Venus. Another, more ambitious, idea involves terraforming Venus. Terraforming would involve altering Venus's atmosphere and surface to make it more Earth-like. However, this concept is far more speculative and faces significant challenges, including the following. Atmosphere removal. One of the first steps would be reducing the massive amounts of carbon dioxide in Venus's atmosphere. This could involve using technology to sequester or remove carbon dioxide, possibly by using solar sails or other large-scale interventions. Some have suggested sending microorganisms that could convert carbon dioxide into oxygen, but this would require technological advancements far beyond our current capabilities. Cooling the planet. Venus's extreme surface temperatures are a result of its thick atmosphere trapping heat. Cooling the planet would require massive engineering efforts to remove heat or alter the planetary albedo. Ideas include deploying large-scale solar reflectors or space mirrors to reflect sunlight away from Venus. Creating a sustainable ecosystem. Even after cooling and modifying the atmosphere, the challenges of creating a breathable atmosphere, a stable water cycle, and an ecosystem capable of supporting life would still exist. There is currently no technology that could undertake such a monumental task. Mining and resource extraction. Venus could also be a source of valuable resources, making it a target for future space mining missions. Some possible resources include metallic elements. Venus's surface is believed to contain various metals, including platinum group metals and other valuable resources, which could be extracted using advanced robotics or automated systems. Venus's extreme conditions, however, make it difficult to land or operate on the surface. Energy resources. Venus's proximity to the Sun makes it an excellent candidate for solar power generation, as mentioned earlier. Massive solar farms or energy collection platforms in Venus's orbit could provide a nearly unlimited source of energy for human use. Technological challenges. The technical challenges of colonizing Venus are immense, and current technology is not sufficient to overcome all of these hurdles. Some of the key challenges include materials. To survive Venus's extreme conditions, any human habitats or technology deployed on the planet would need to be made from materials that can withstand extreme heat, pressure, and corrosion from sulfuric acid. Radiation protection. Venus does not have a magnetic field to protect its surface from solar and cosmic radiation. Any colonies or habitats would need to have adequate radiation shielding, either through physical barriers or other technological solutions. Life support systems. Ensuring a reliable life support system that provides oxygen, food, water, and waste management for humans would be crucial. These systems would need to be self-sustaining or able to operate independently of Earth for long periods. Transportation and logistics. Getting to Venus and sending supplies or personnel would be extremely challenging. Venus's gravity is similar to Earth's, but the atmosphere's density and high wind speeds would complicate the design of spacecraft and landing systems. Any crew or supplies would also need to be shielded from extreme heat and pressure during the descent. Space agencies and research. While no current space agency has plans to colonize Venus, there have been missions and research dedicated to studying the planet. Some notable missions and efforts include NASA's Veritas, Venus Emissivity, Radio Science, INSAR, Topography, and Spectroscopy. This upcoming NASA mission, set to launch in the early 2030s, aims to study Venus's geology, surface composition, and tectonic activity. ESA's Envision mission. The European Space Agency is planning a mission to study Venus in greater detail, looking at its atmosphere, surface, and geologic history. Russia's Venera program. The Soviet Union's Venera program in the 1960s and 1970s was the first to send successful probes to Venus, with the Venera 7 in 1970 being the first to land on the surface and transmit data. However, the harsh conditions only allowed for short-duration observations. Future prospects. While colonizing Venus remains a distant prospect, there is still significant interest in studying and exploring the planet. Advances in space technology, materials science, and atmospheric processing could eventually make it possible to establish a permanent presence, either in the upper atmosphere or on the surface, over the next several centuries. In the short term, robotic exploration and scientific missions to better understand Venus's composition, weather patterns, and atmosphere could provide the foundation for more ambitious projects in the future. Conclusion. In conclusion, while colonizing Venus is a captivating idea, it is fraught with immense challenges, from its extreme environmental conditions to the technological hurdles involved. At present, the idea remains speculative, but ongoing research, along with the exploration of Venus and other celestial bodies, may one day make such endeavors possible, likely starting with floating habitats in its upper atmosphere rather than attempts to colonize its harsh surface.